So in this problem, we have to deal with this very, very interesting situation in which a guinea pig runs on the rim of a horizontal wheel. This is the guinea pig right here, and this is the wheel. We are given all this information, the mass of the wheel, the radius. This is the mass of the guinea pig, and the speed with respect to the ground, and that's important. And we are supposed to find the angular velocity of the wheel while the guinea pig is running around this way. So what do? We start with the angular momentum before the guinea pig is running. At that point, nothing is rotating, so we can say the total angular momentum before any motion is 0. That means that after the guinea pig starts running, the total angular momentum must also be 0, and that is because the net external torque acting on the system is 0. So this is a case in which the total angular momentum is conserved. That means that the sum of the angular momentum of the guinea pig plus the angular momentum of the wheel must be 0, and remember that these two are vectors. In this case, they point in opposite directions because while the guinea pig runs around this way, the wheel is rotating in the other way. So from this one then we have for the guinea pig I times omega, and for the wheel I some w omega sub w. And this should be 0. That will give us then what we want, which is the angular velocity of the wheel as omega times I divided by IW. And now we have to reduce this to the quantities that we have. Omega is going to be V divided by R, and then I is small m R squared, and IW is big M R squared. And I can happily cancel R squared in this expression. I'm going to be left with omega W equals V divided by R small m divided by big M. I have all the numbers that I need now to find the numerical answer of 0.125 radians per second for the angular velocity of the wheel. And I can say also that the wheel is going to rotate this way, which is clockwise. This symbol is representing the omega vector pointing into the board. Another question we can ask, an additional question, is what is the linear speed of the guinea pig, not with respect to the ground as given to us, but with respect to the wheel? Let's call that V prime. V prime, which is the speed of the guinea pig with respect to the wheel, we expect it to be larger than this one because the wheel is rotating the other way, so this number should be larger than 20. So how do we do that? We have to calculate how fast the wheel is rotating. So that's going to be whatever we had before, which is 20 centimeters per second, plus the speed of the wheel. Now the speed of the wheel is omega W that we calculated times R. Because I don't have room, I'm going to write it right here. Omega W times R. If you put the numbers in, you will get 25 centimeters per second. So as you can see, you can always make the problem more complicated than given.